In the last session, we have seen various types of lists are possible, like arrays, linked list, doubly linked lists, and many more to follow. So to begin, let's concentrate on these three and see how they are implemented, how they are used, what are their pros and cons in actual usage and all. So the operations that can be performed over the list is creating a list, adding a new data to the list, retrieving a data from the list, deleting a data from the list, updating the data from the list. Yeah, these are some operations we need to look at. So let's begin with the simplest way of implementation, and that's called an array. Array is a set of sequential memory locations reserved to store data. Each array is given with a name, and the array is known by this particular name. Then each array has got a fixed size. Then it has got a fixed data type. So these are some of the issues of an array. So if you just look at a memory location, so that's a memory, and talking of some sequential memory locations. So that means part of memory. So if we want some memory for, say, an array is A and has got some fixed size, say length of the array is, say, L, and data type maybe say character, that means 1 byte per data. So in this case, we find out a portion of memory. So when you say the size of the memory required, for this array will be, so we have L items in the array, and each item, because it's a character, is going to take 1 byte of memory. So totally L bytes are required. So you just identify a location where consecutively L bytes of memory are available for usage, and if you find any such thing, then call that as the array A. So that's how it's implemented. So we need a consecutive memory locations, so I can better call it a consecutive. That makes more sense instead of sequential. So consecutive memory locations are required, And this may not make sense in the beginning, but as we keep adding an array, deleting an array, adding an array, deleting an array, if we keep doing this, then we would have added some array, we would have added some arrays on the way somewhere, and so on. Now, when we want to add a new array to our memory location, say E. So we need just find out what is the size, how many entries are there in the array, and what type of entries are there. If it is character, then 1 byte per character or 1 byte per entry is required. And if it is say 2 byte integer, or it can be int 8, then 1 byte required. Int 16, 2 bytes are required. Int 32, 4 bytes are required. Int 64, then 8 bytes are required, and so on. So depending on that, the size into the memory required for that, just find out the total memory required, and then search for it. So can we accommodate in this blank space? This is blank, this one is blank, this one is blank, this one is blank, and this one is blank. So if this new array is having a very big requirement, then it will not be accommodated in this, will not be accommodated in this, may not even be accommodated here, may not even be accommodated here, may not be accommodated here. So even if so much of memory is still free, so when you look at the details, how much memory is being occupied, how much memory is available free, then you will find the size of the free memory is much more than what was required. But when we try to implement this as an array, it says that no memory to implement, so implementation of this array fails. So that's one drawback of this array. Now coming to the various types of operations. So when it comes to create, so we just define. So if you are working in a C language, then we could say integer a of size 100. Yeah. So we are trying to say that a is name of the array. This is the type of the array, and this is the number of elements we have. So in C, if you look at it, data type int requires 2 bytes of memory per element. So in all, the total memory required will be 2 into 100, that is 200 bytes. Done. So that's how can be created. Then how about adding a new array, a new value to that? So if you want to add, say, second element, you want it to be 20, then simple. In C, we can just say 20. I'm sorry, must be 19. Second element. So in C, the index starts from 0, so on. So that's our first element. That's our second element, and so on. So A of 1 will be 20. So that's how we can add into the. Want to retrieve? Then just say so you want to retrieve and place in some location. So you say A is equal to capital A of 1. That means after this is executed, the value of A will be 20. So if you say print A, then we get a value 20 on the screen. Okay, the next operation would be deleting it. So here, delete operation is not available. Then yes, of course, we can update. So if I say A of 1 is equal to 40 and run this line, then now onwards there will be 40 placed in this location, which is indexed by 1. That is the second element of array A will be 20. So the pros, it's a simplest way of implementation. So for arrays, if you just look at pros, simplest implementation. And even the fastest possible. Does require consecutive locations, so that needs consecutive memory locations. That's one thing. Second thing is we need to define size in advance. That means the size of array is fixed. So that's what we call static allocation. So memory is allocated on the static basis, so cannot modify size dynamically or in runtime. In advance, we say this is before compiling, we have to make sure. So what is the size of the array you need? So this has to be decided before compilation. So this is not possible to change in the runtime. So that's array is can create array, can add data to the array, can retrieve data from the array. There is no option for deleting any element from the array. Yes, of course, we can update the data value in the array. It's a simplest implementation, fastest way of implementation, fastest way of adding, fastest way of retrieving, all are possible. So fastest addition of data, then retrieval, and what else? Updation. So all this fastest possible because it's done in a random basis. So the address selection is done randomly. That means in this case we said a of 1 equal to 20. Yes, it goes to the second location, makes it 20. And if you say a of 20 is equal to 30, then it goes to 21st location and adds 30 there. So whether it is a of 1 or a of 20 or a of 99, whichever location you tell, all are done with the same time. So it's require execution time the same for all these operations. So how does this differ? Why we are saying about 120 or 99 and all that? Yes, that's of course very clearly visible when we get into the next item, which is called a linked list. So there, these are going to be a big problem. But of course, with this, we have random access possible, and hence every location is equally accessible. So adding at any location, retrieving from any location, updating values at any location are done at a constant time. So I could better call it all these operations are done at a constant time. Doesn't depend on the size of the array. Done. Needs a consecutive location. That's the negative side of it. Need define the data size should be in advance. Size of the array is fixed because we have to define in advance. So once you define it before compile time means it has to be part of the program. So when you type some value in the program, then it can't be changed. So that's what before compilation, whatever you type is the final one. So whatever is done during at the compile time is final here, can't be changed after compilation. Then size of array is fixed. It's also called static allocation. We cannot modify the size dynamically. So or dynamically in the sense in runtime. All these issues we can clearly see when we work with the next item, that's linked list. So keep watching for both coming sessions. Thank you.